Chair Zimmer,
Here.
Director Sesena is on his way.
Okay, we should expect to see him shortly. Okay, item 3, pledge allegiance.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Okay, at this time, we're going to make a little change to the agenda. We have Spencer with us, and just out of consideration at his time, we're going to move to our action items 9A and 9B and 9C. So, I was hoping that was Chuck, because Chuck should really be present for these.
We could, well, maybe start with 9C. So I think we do need unanimous approval
Yeah.
because it's not a budgeted item, so we could do 9B.
Okay.
We're trying to get through the action items as quickly as possible.
Yeah. Still takes approval on 9C. All of these.
Takes unanimous approval.
I believe 9C would require unanimous approval as it's not.
It's the contingency.
Well, I guess, yeah, it's kind of out of our rollover from LA 1416.
Yeah.
And 9B is a receive and file. It doesn't,
Okay.
and so is 9A, but yeah.
Well, 9A's more important, I think, than 9B. Let's start with 9B. How about that? We'll start with the presentation on the AME or AEM results.
Thank you, Chair Zimmer. Yeah, so 9B, we have a memo. Presentation is probably a bit of a stretch on the AAM results. But as the board knows, about a year and a half ago, I believe, DWR performed an aerial electromagnetic survey of the Los Osos Basin as part of a larger effort that they were working on. It was actually a favor of DWR to fly Los Osos because we are not a SGMA or Sustainable Groundwater Management Act basin, but thanks to some good advocacy from the BMC and others, they did fly our basin to collect some additional data while they were in the area. That data has been available for a good bit of time. Sorry, I'm struggling to get my agenda packet to pull up. My computer died this morning, so bear with me as I don't have all the details. But we had a request from the BMC to get a report or a presentation on what were the findings, or what data and or information were we able to obtain from the AEM survey. And so, thank you, Jamie. So we've got, while we have Spencer here, I thought that maybe probably the most efficient thing to do would to have Spencer just come up and talk briefly about what we're able to learn from the AEM survey, and just speak to his technical memorandum.
And provide you a space at the table if you want, Spencer.
That's fine. Thank you. Chair Zimmer, directors, good afternoon. I'm Spencer Harris, Cleatheris geologist. So, the AEM data was collected, as Dan said, by the DWR, and initially CHG provided DWR with our logs and information on the basin so that they could use that information to calibrate their findings or their results. So the process was to fly a helicopter about 100 feet above the ground and to send pulses of electrical magnetic fields into the ground. And unlike what we call a electric tomography resistivity survey, this is a time domain survey. So as the helicopter's flying, it's pulsing this data and then reading the residual magnetic field that results from the interaction with the ground. It's a circular array, and the focus is at the middle of the circle. And these reactions are on the order of milliseconds in terms of how it's pulsing and reading. So the helicopter can fly at a certain speed, and it's not going to blur too much of the data because it's fairly instantaneous of the data it's collecting as it's moving along. So with this technology, they can see up to 300 meters or about 1,000 feet underground if the conditions are right. And so they did fly some flight paths over the Los Osos Basin, and the results, what I did for this memo, and I don't know, do you have the memo on?
Yeah, so the memo is included in the agenda packet, but we don't have the full memo and slides.
Okay. Well, I mean, I have it if you want it, if you want to show it, or we just proceed.
I think really kind of what we're looking for is just real high level overview
Yeah.
of, and I think, we've kind of covered the data collection and maybe we jump to findings. And I mean, if there's detailed questions about
Okay.
how geophysics surveys are performed and others, maybe we can
All right.
deal with them elsewhere.
Interesting as those questions are. Yeah, I think your findings and conclusions.
Okay. So the findings basically, under the bay and the dunes, the sand spit, the findings were that there's salt water, there's brackish water, which is not surprising. And what we wanted to get out of this survey was really to see if we could delineate the extent of seawater intrusion, because our information on the structure and the lithology of the basin is actually what they use to calibrate their instruments. So the AEM data was not going to inform our subsurface modeling, where we had a lot of data, a lot of real, hard borehole data. So in terms of the extent of seawater intrusion, it did show again that there were areas beneath the bay that were intruded, which we knew, and it did denote some of the things that were supportive of the model in terms of fresh water beneath the sand spit, fresh water in certain zones and certain areas of the basin. So I don't think there were any surprises coming out of that. There was one area up towards the north eastern side of the end of the bay where Los Osos Creek comes in and Chorro comes in, where the transient model doesn't have intrusion in the upper aquifer in that area, but the aerial magnetic survey did show intrusion. But if you look at that section in particular, it was it also showed that basin sediments went down 400 feet at the basin boundary where we have lithology logs that indicate shallow bedrock. So there's some issues with that area for the EAM survey. So I'd say, the resolution of the model or the survey for structure and lithologic delineation of the basin is not good enough. It's not high quality enough to use in the transient model, but it does give us the the areas where we see seawater intrusion that we can then confirm with what we find in the model, and there's general concordance. Okay. So any questions or
Okay.
follow up on that?
All right. Any questions from the board before we go to public comment? Spencer, I have one question for you. So this feedback that you're getting, was it primarily for the upper portion of the basin, or can this pulsating and feedback go through the aquatards and actually get into the different, do we know, I guess, the different basin levels that had the concentration of chlorides in it?
Yes, it does. It is able to see down deep.
Okay.
As the deeper you get, the larger the blocks are. So there's 30 layers, and the top one's 2 meters thick, and then the report doesn't tell you how large the lower blocks, but the resolution is much less, but it can see that deep. Where you have the seawater, because seawater is a high conductivity, it gives low resistivity, which is similar to a clay. And so there's once the seawater influence shows up on the AEM data, there's no further interpretation that can be made on the lithology, because it all looks like clay. And so the parts of the flights that you can see deep are the ones without the saline influence are shown in blue there. So
Yeah, I don't know if this is helpful or not, Spencer, but I mean, here's one of the figures from the TM.
right. So that figure's showing the pink. So there's 3 different profiles given: a Sharp model, coarse fraction model, and the uncertainty model. The Sharp model is the raw data, resistivity data. The coarse fraction model is the interpretation of the lithology based on that data. Then the bottom is interpretation of uncertainty. In the middle one, which is the coarse fraction, you can see the pink, and that's all saline influence. So that's all blocked out. There's no interpretation there. And you can see above it in the raw data, it's all blue. So they determined, and again, we provided boring logs. And so they were looking at that, presumably, and seeing that you had gravels, but it's showing blue, so it must be influenced by saline water.
Okay. And it is the contour of that chart based on the level of the aquifer or the concentration of chloride?
Well, the depth, so there's resistivity for the Sharp model, which is the raw data, resistivity along the x-axis, and then there's depth in meters. Elevation, actually, not depth. So it's elevation in meters. So that's from 0 goes down to about 300 meters there for the readings.
Okay. And then just lastly, is this something that would be worth doing again in a certain time interval, like 5 years or 10 years or something? Would we get better information, more information, anything that?
Well, I don't know that would be worthwhile. I think, what the one area that was interesting is where it came in actually and flew up the old Tri-W, the middle of town site. And there it showed no seawater intrusion. Okay. But we have a monitoring well at Skyline where we have intrusion. We know it. We measured it, and we can see it in the E-log as well. And then we had intrusion at Palisades on the other side of that flight line. So if you look at the uncertainty for that particular line, it gets relatively high as you go deep. But what we want to do is go into that area and then run a land-based line. So an ERT, which will give us better resolution. And we're working with the National Estuary and funding for that. So that's a grant application. So that will be something that if we are able to see it, that if that can be repeated over time, because that would be right in where the front is likely to be, where
Yeah.
we'd expect it.
Okay.
If I could, Mr. Chairman, would it be fair to summarize, Mr. Answer, that the limitations of the aerial electromagnetics is really where it can fly, because it can't fly over a built environment because all the electromagnetic interference of the structures in there doesn't allow it to penetrate. So that's why you see the tortuous route on the one on the far the bottom. You see nice straight lines where there's a nice open area, and the issues of most interest are underneath the built environment. So interesting, nice. An interesting experiment, but not really so relevant to what we're doing.
Right. And where we would like to get structure, which would be offshore, it's all wiped out by the seawater.
Yeah.
I also have one question. Thank you, Spencer, for going over this. My question is related. You had said that I think you said was it the Northeast? There was an indication of seawater intrusion where we hadn't previously. Can you show on the map where that was?
Sure. So right over here. So it's just where, like I said, where Los Osos Creek and this is where Chora Creek come in. It's flight number, this is 100, 200 here. This is 200, 400 going down. But this flight, you look at the far end of the flight, the east end, see it shows intrusion, but then it also shows a very deep profile for the basin. And actually right here, we drilled a test hole and hit bedrock. So it's not 400 feet deep there.
Okay, interesting.
So there's some discrepancies with the flight interpretation.
Okay. Do we have that flight? Is that flight path one of the ones that's
Sure.
depicted?
Yeah, they're all there.
Okay. All right. Thank you.
Mhm.
Okay, thanks, Spencer. Appreciate it. We'll go to public comment on this item 9B.
If you have a public comment and you're in the boardroom, please come up to the podium. And if you're online, please raise your hand. We will take public comment in the boardroom first.
Hi, Lynette Brooks. It is good that the model mostly matches the AEM data about salinity under the bay. This is a much more realistic simulation than the previous model. Using the AEM to determine saltwater exists under the ocean and under the bay, however, hardly seemed necessary. The real point of the AEM, and the reason the model was delayed, was to use it to refine the definition of the geology. It is discouraging and somewhat surprising that Cleith Harris geologist found the AEM data was not of sufficient quality or resolution for the development of a hydrostratigraphic model to inform the transient model on basin lithology or structure. That was all a quote. This is surprising because the DWR webpage states that AEM supports the development or refinement of hydrogeologic conceptual models and can help identify areas for recharging groundwater. The DWR has developed a lot of tools to analyze the data. It seems strange the DWR would keep using AEM and developing tools if it was not working for the intended purpose. Most of the figures presented in the report by CHG about the AEM do not show the distinct layers in the system as conceptualized and simulated by Cleith Harris geologist. I can't help wondering if CHG doesn't think the data is good enough because it doesn't support the model assumptions of separate aquifer layers. The model does a poor job of simulating seasonal changes in Zone E, and a really poor job of simulating arrival time and steepness of saltwater intrusion. It is possible that changing the definition of the layering could improve those fits. Thank you.
Thank you.
Ready? Good afternoon, Lindy Owen from Los Osos. I'm a little bit confused because I actually have a photograph out by across from the cemetery of the helicopter with the AEM doohickey flying at a very low level. So when I look at where it supposedly flew here, and is the blue line, oh, blue is the flight line. So it was out there. My question is, I still believe that our basin and the adjoining basin are connected in some way. And it's dangerously overused right now. If you look at the amount of farming that is going on past Foothill, it's shocking. It's more than doubled, maybe close to tripled. In other words, pulling the water out of that basin, if they're connected, will affect our basin flow. These are ancient places. So I'm wondering if Spencer could explain whether that shows a difference between where we supposedly have a volcanic ridge that separates the two basins, because I am very concerned that if we're not careful, we may be giving away all our water to another set of industrial farms that have popped up. Thank you.
There's no further public comment in the boardroom and there's no public comment online, so we'll take it back to the board.
Okay, thank you. I think overall on that general comment there, Spencer, you're pretty confident in the basin boundary and that influence, right? Yeah, we've studied that. Okay. Okay, thank you. Sorry, bubbling here. We'll now move to, I just want to welcome Chuck. Welcome, Chuck. All right. Chuck's with us in the boardroom now, so we're going to move to item 9A.
Yeah, thank you, Chair Zimmer. So item 9A is an item we had originally brought to the BMC at our June meeting. Unfortunately, Spencer wasn't able to attend and present at that meeting. So happy to have Spencer here today to present on the transient model, construction and calibration, TM and baseline scenario technical memorandums. Sort of in the interest of time, I'll probably skip over the history of how this project was identified and funded. We've covered that at previous meetings, and really jump to the presentation that Spencer with Cleith Harris Geologist will be providing. But because I think that's what we're all waiting for. But I do just want to add a couple of, introductory comments. The transient model is a tool that we've been working a long time and putting a lot of time and effort and money developing. We've chased and obtained grant funding. We've received contributions from BMC parties, and we've leveraged other expenses as match. Basically, we've clawed together as best as we could enough money to develop this tool. And this is a technical tool for the BMC to consider for utilizing and improving our understanding of the basin and better predicting, what future basin conditions may look like, and also evaluating how projects and management actions may or may not, and to what extent they can be beneficial in improving basin conditions. And so today we're going to get a presentation, what I would characterize as a very technical presentation on the construction of the transient model, the calibration of the transient model, and then just one initial scenario that the transient model was utilized to run. It's what we're not doing here today is making any sort of policy or sustainable yield decisions or any of those types of actions. This is a really an informational presentation with an opportunity for the board to provide feedback to staff and consultants on, the technical tools that are under developed. we do have policy decisions and things that are going to need to come to the BMC, and those are going to come at future meetings, likely in the form of adoption of a sustainable yield for calendar year 2026. And then, other related decisions, that may come from that. But, today really the focus is on the technical piece of this. And so I just want to sort of lay that groundwork as I turn this presentation over to Spencer with Cleith Harris Geologist.
Thank you, Dan. Again, Spencer Harris, Cleith Harris Geologist. And I'm going to present the Transient Model Construction Calibration Report, and then a brief summary of the current condition baseline scenario. Before I begin, I want to introduce Tim Kershaw. He's an environmental scientist with Cleith Harris Geologist. He built a lot of this model, and he's run the scenarios. So just want to acknowledge him for all the hard work that he's done on this. Okay. I'm going to try to keep this to go pretty quickly through this. So, we can come back and get into the weeds, but I'm going to try to fly pretty quickly through this so that there's enough time for all the comments and questions. So this transient groundwater model is part of the water recycling facilities planning study. Some of the purpose for creating the model or updating the steady state model was to, the main thing to evaluate basin yield. We want to overcome limitations of the steady state model. So, we can account for variable hydrology or climate, phasing of projects, extended droughts, transient stream flow. We have, planning horizon capabilities and other time-dependent factors. Also want to improve the simulation of basin dynamics. So we're able to get an order of magnitude more calibration data, including the basin response to the sewer project, which, was between about 2016 and present. So we have all that new information to calibrate the model to. We can evaluate groundwater surface water interaction with a streamflow routing package, which the steady state model wasn't able to accommodate through the code. And then we can update it with the new basin information, the latest well data, aquifer tests, and water quality. Ultimately, this transient model is part of the package that included an engineering study, recycled water and supplemental alternatives. And I know most of you have seen the presentation by WSC on that. So we're supporting WSC in that engineering study to try to optimize the use of recycled water. Okay, I've broken this presentation into four parts. First, just a real brief conceptual site model description, the physical system, then model construction, model calibration, and then the baseline scenario. Next slide. All right, this is an older geology map, Hall, and what I like about it is that we've put the offshore geology on this map, so you can get a better sense of the overall picture of the basin. The dashed line is the basin boundary, and you can see it's oriented kind of northwest to southeast in the length of it, and it's between these bedrock, what they call structural blocks. So there's the Moros to the north and in the Cambria block, and then there's the Irish Hills to the south and the San Luis Pismo block. The Los Osos Fault is a prominent feature along the southern boundary of the basin. But the offshore, there's been bedrock mapped offshore, and so we can suppose that the basin boundary moves upwards, as you can see the three circles that delineate where the extent of bedrock is visible on the ocean floor. And if you project that up, the basin sediments can go maybe a few miles, 3 miles offshore. And then onshore, it's about 5 miles. So that's the big picture for the base boundary. And these are some plan areas. These plan areas you're probably familiar with, but they're referred to in the reports, annual reports, and the basin plan, and they're useful for trying to describe where things are happening in the basin. So you have the dunes and bay area, the western area, central area, and the eastern area. We have multiple cross sections that go through the basin, and two of them I'll show you here. The BB prime is the longer section from west to east, and then EE prime is the shorter section from north to south. So this is BB prime, the longer section, and it runs for about 5 miles from the sand spit near Sharks Inlet over to Warden Lake. The basin bottom extends close to 700 feet below sea level on the west, and then rises to about sea level on the east. There are two main water supply aquifers that we monitor for seawater intrusion. The upper aquifer, which is also called Zone C, and the lower aquifer, which is divided into zones D and E. There's seawater intrusion in both zones D and E of the lower aquifer in the western area, and the dunes and bay area, which is shown on that cross section in the colored shading. The upper aquifer, Zone C, has really no intrusion except in the dunes and bay area. So as you go under the bay, then you will have the intrusion, as we saw in the AM survey and in the model in Zone C. But as you move on shore or over land off the bay, it's all fresh water. The gray shaded areas or layers are area lakes and extensive clay aquatards that are interpreted from e-logs, and they extend across the basin. Next slide. So this is the north to south cross section. Clay aquatards aren't shaded, but they still carry through. Seawater intrusion you can see in Zone E and a small portion of D. There, you can also see the lines reflecting the synclinal nature of the basin, which is kind of a U-shaped structure to it. Okay, next slide. So that was just a brief conceptual site model summary, and now we'll go right ahead into the model construction. You can see that those are the different topics that I'll cover. So model code, platform, ModFlow USG transport. That was built, that was originally developed by the USGS and is now supported with updates by private industry. ModFlow USG is one of the most widely used flow model codes, and it's coupled with the platform we use for model construction is Groundwater Vistas, and that's an industry-leading modeling software. Next slide. So this is the model grid. I mean, it's hard to look at because we have the grid turned on, which, you know, are all the small squares. So it's a little difficult to stare at. But this is the model grid, and it shows some of the boundary conditions that we have. That black line is the synclinal axis of the basin, which is the middle of the U-shaped folds that go across from west to east near the middle of the basin. Los Osos Creek is the long orange line on the east side. And there's also some faulting along the southern border near the creek there. And the ocean and bay are in green. Drains are yellow. There's a drain at Sweet Springs and a drain Warden Creek at the north end of the creek valley. And then the general head boundaries are light blue there. The grid itself is 200 foot on a side. There's 90 rows, 150 columns. The orientation of the grids perpendicular and parallel to the synclinal axis, so that there's less artificial dispersion in the model for transport. And the grid domain covers the Los Osos Basin Plan boundary and goes a half mile offshore. Now, as I showed you, the sediments can continue for a few miles, and we set the general head boundary there a half mile offshore to project farther out. There's no need to run the grid all the way out. So next slide. Oh, if you could go back one, let me just point out the yellow lines, which are cross sections in the model that I'll show you on the next slide. So these are the model layers, and these are the top sections are south to north, and the one on the top left is through the bay, and the one top right is through the downtown area. You can see again the U-shaped folding or the syncline. The axis or the center of the folding stays more or less consistent through downtown, so it just goes down the basin in elevation. But on the west, that axis, that fold kind of drifts to the south, and then ultimately you just don't see it. It's just a dipping bed at the bottom. The lower section is west to east through the middle of the basin. The layers appear more or less flat because they're parallel to the synclinal axis, and then they rise up to the creek valley. So these cross sections aren't exactly where the basin sections are drawn manually, but you can see the similarity. And the model layers were created using lithologic logs and e-logs of close to 200 boreholes across the basin. The layer 1's the upper aquifer, layer 2 is the regional aquitard, layer 3 is lower aquifer zone D, and 4 is the deep aquitard, and then layers 5 through 7 are divisions of the lower aquifer zone E. So here's a summary of various boundary conditions in the model. So boundary conditions are mathematical packages used to constrain flow in a way that represents the physical system. For example, at the ocean, we use a river package to represent the ocean water body. And then for the aquifers under the ocean, we use general head boundaries to extend them offshore to the point where we assume there's seawater top to bottom in the model. And the bay is also simulated with the river package. And I'll explain briefly how this works. So you, in the river package, you set a stage elevation or a water level in the surface water body, and then a bottom elevation for that body, whether it be the bay or the ocean. And then there's a bottom conductance value, which is kind of a permeability-based value. And so when the water pressure in the aquifer is above the water level, let's say in the bay, then water flows from the aquifer up through the bottom into the bay. And when the water level is below that bay water level, then the bay can flow into the aquifer. Now, what the difference between the river package and say the general head boundary is that when the water level falls below the bottom of the bay, then there's a leakage factor where it's a constant flow. Whereas in a general head boundary, it's only based on the difference in head on either side of the boundary, and it just keeps getting more and more flow in either direction based on that change in head. Whereas in the river, there's a cutoff because the water bodies have a finite thickness, and then they're underlain by their bottom. So that's just a hopefully understandable description of that. So the river package handles dual density flow or density dependent flow. So it was the, appropriate choice here for these water bodies. There's other packages, other boundary conditions. The Los Osos Creek uses a stream flow routing package. And in that the stream can actually go dry, or it turns itself on and off. You can put water in the upstream cell. So the upstream part of the creek has water introduced to it. And then the model calculates how much water seeps into the underlying aquifer and how much moves on to the next cell. And it just repeats that process through the outlet of the creek. Now you can also have, again, based on the base of the creek and the elevation of the groundwater, you can have water coming into the creek too. You can have rising water in the creek. So it's just another reflection of these boundary conditions, which are, they're similar, but there are differences based on the specific application. The streamflow routing package doesn't accommodate density dependent flow, but we're in the creek valley. There's no seawater intrusion, so there is no really impact on functionality of the model for our purposes. Next slide. Okay, aquifer parameters. We have hydraulic conductivity, specific storage, specific yield, and these are based on a combination of pumping tests and lithologic correlations. For the hydraulic conductivity, which is the main parameter controlling flow, we digitized the borehole lithology of 40 key wells across the basin, and then classified them into 4 groups from low conductivity to high. And then the results of 18 pumping tests were used to calibrate the hydraulic conductivity value correlations. So we, entered hydraulic conductivities for the 4 groups to try to create the best match to the aquifer tests. And, it was pretty successful. If you look at the overall averages, the match between the lithology-based hydraulic conductivities and the pumping test was 5%. So on this slide, the colors, the yellow is the best match. Green is the same order of magnitude, and the red is a different order of magnitude. Now, hydraulic conductivity can go over several orders of magnitude. So even if you're in the same magnitude, that's pretty good. So we did the same thing for storativity and specific yield, but that was really based on lithology only. We'd have one good calibration point for specific storage from a test we ran at Palisades and monitoring the new Skyline monitoring wells. But once we had correlated these values, the K values, then we applied them to 40 key wells across the basin to create fields of permeability and storativity. And we did insert some surrogate points so that the kriging process wouldn't have artificial edge effects and so forth. So they were loaded into the basin, into the model. Okay, next. The recharge preprocessor was used to estimate and distribute percolation, precipitation, return flow in the model. The concept was originally developed for the steady state model by Yates and Williams, and I think it did a good job of representing local conditions. So CHG completely rebuilt that for the transient model. So he basically built it from scratch, different code, and there's 49 recharge zones representing 8 land cover types with updated overlays for the perched aquifer effects, sewer collection zones, and community leach fields. The recharge package processes rainfall to estimate deep percolation using a soil moisture budget. We also used OpenET satellite data to refine crop coefficients for the Los Osos area. Runoff coefficients are based on slopes and land cover, and were used to estimate runoff, which was routed to the creek or the bay. A recharge to the perched aquifer was redistributed to the underlying upper aquifer through leakage and perimeter zone spill. So the perched aquifer is not explicitly modeled in the transient model. The same as was the case for the state model. There's just too much vadose zone. There's too much unsaturation between the perched areas of that aquifer in the sands and then the underlying upper aquifer to make it practical to put it all in the same model. So that's why it was handled with the recharge preprocessor. So this illustrates the hydrologic base period for the transient simulation. The base period for the model runs for 45 years from 1979, water year 1979 through 2023. This plot here is the cumulative departure from mean precipitation curve, goes back to 1955 using rainfall, excuse me, from local rain stations. You can see the 45-year base period is fairly well balanced. So if you look at the little red circles there, the one is water year 79 and then forward to 2003, and they're right along the zero cumulative departure curve. So it's very pretty good match for what we call a base period. The average annual rainfall for the base period is 18.3 inches, and it covers multiple wet dry periods. As I said, we cobbled together actual rainfall data from multiple rain stations around Los Osos, and we want to do that versus use Morro Bay, which has been used in the past for the state model, because we wanted to get the actual storm events coming through, in Los Osos to try to capture that over time, because things are different actually. So the transient model uses the hydrologic base period as the calibration period. So that's the calibration period is also the 45 years. The model runs in quarterly stress periods. So there's 180 stress periods in all. Density dependent flow parameters are based on seawater and freshwater densities and chloride concentration. So the seawater, the chloride concentration of seawater, 18,565 milligrams per liter. And then that is assigned a seawater density of, 2.5% greater than freshwater. And then the model will calculate the densities and give us direct readings of chloride as for output, which is nice. The state model worked in TDS and cubic pounds per foot. So this is a more direct way to see what's going on. The transient model uses the hydrologic base period as the calibration period. Yeah, I mentioned that. Okay, next slide. All right, these are the water budget input data sources. We've got rain stations, a stream gauge, wastewater data from the offset study and from Los Osos water recycling facility records, and we have meter water production from the purveyors. Other water budget inputs involve soil moisture budget for irrigation pumping and return flows. And then the rest of the inputs, mostly subsurface inflow and outflow, are estimated by the model, some of which we checked against flux calibration targets, so analytical calculations of underground flow that we then compared to the transient model. Next. Okay, we're moving right along here. Calibration, next. So streamflow calibration, basically this graphic shows the flux in cubic feet per day of flow, simulated flow, which is in the blue dashed line, compared to the computed or the measured flow, which is the red. And some of we developed a rating curve for the Los Osos Creek gauge, which allowed us to update the stream flows, which had only stage data for years and years. So we got actual volumes. And then we used a basin characterization model or the Clark Valley watershed to backflow flows for missing years. So we then had a full set of flows, both real and simulated, for the creek. And then those were loaded into the transient model as inflow to the, in the streamflow routing package. They were loaded at the top of the creek as the creek comes into the basin. And then towards the end of the calibration, we made some adjustments because, when the creek comes in, it actually recharges the basin. And so you have to put more water in than you're reading at the gauge because some of that water is lost as it moves through the basin. So those adjustments were made. And, it's not a great distance between the gauge and the upstream part of the basin. And so the computed flow averages were actually 99% of the measured flow. I mean, they were very, very close. So with the raising the simulated or the measured flows by a certain amount and putting it at the top of the basin, then the calibration was, as good as it can get, really. Next. So the water level calibration, we calibrated water elevation in feet to, there are over 3,000 water level targets across the basin in the calibration period. We used mapped residuals and target hydrographs, and we made adjustments to various parameters in the model during calibration. Once water levels were calibrated, then we had to go back to the seawater intrusion calibration, the chloride calibration, because they interact with each other with the density effects. So the process was iterative. The statistics are listed there on the bottom left of the slide. The residual mean is the average of all the model residual error. And, if you look at the graphic shows observed versus computed target values. So observed value in feet, elevation on the X, and then model values on the Y, computed values. And then these are the differences between the two. So observed minus computed. And the diagonal line represents the perfect fit. So that would be, where it reads 20 feet. If the model measured 20 feet, it'd be 0. And it would run right through that diagonal line. So the residual mean is the average value of all the model residual error based on observed versus computed target values. Some of the residuals are positive, some are negative. In this case, the average is balanced at less than a foot. So the residual means 0.55 feet for all the 3,000 plus targets, which means it's not biased above or below the perfect fit. It's kind of spread out along that diagonal line. The root mean square error indicates the average magnitude of the model water level, and that's plus or minus 10 feet. The scaled calibration statistic is 5.8%. The industry standard is 10% or less, so it easily meets that standard for calibration. Next. So these are some of the hydrographs for visuals for the water level calibration. These wells are for the upper aquifer, including first water wells. The red lines are measured values. The blue lines are computed by the model. You can see the model is pretty good at tracking water levels through time. The top middle plot shows the Broderson Mound developing at FW6. So the water levels at FW6 are within 10 feet of the measured levels at the start of the wastewater discharge in 2016. And then they rise to within a few feet of the observed mound elevation over time. So that's one of the things that we wanted to calibrate for the sewer project effects. When we have where we have a full 45-year record for a well, the water levels in 1979 are often close to what they were in 2023. So, again, it's makes sense since this is a base period, you know, that things kind of came back to where they were. Next. This is the water level calibration for the lower aquifer, zone D and E. There's more in the report to look at. In fact, all of them are in the back as part of the peer review, GSI's peer review. Everything is there to look at. So a couple of wells are not showing as much seasonal fluctuation in the model as observed. So the computed water levels they're just, it's kind of a line that moves flat, whereas the measured water levels show some seasonal fluctuations, but we still have good tracking in terms of the overall pressures. So it's still good calibration from that standpoint. Next. So this is the groundwater flux calibration. So flux is really just flow through a given area, really is you think of it as groundwater flow, but then you have to define, well, where is it flowing through, you know, out of a garden hose or through a cross-sectional area underground. In this case, the model was compared to some analytical estimates developed using Darcy's law for 2001 conditions. This was done during the 2005 seawater intrusion study, so that information's there. And three major components of subsurface dynamics were compared. So we looked at seawater intrusion, so seawater across the ocean boundary. We looked at upper aquifer leakage, so mainly in the central and western areas, you know, how much water was leaking through the upper aquifer into the lower aquifer, and then inflow from the creek valley. So that cross section shown on the slide there is the creek edge of the creek valley, and you can see there's some of the hydraulic gradient numbers listed. The eyes are DHDL, the rise overrun, part of Darcy's law. So if you look at the analytical results versus the model results, they're a really good match. And, you know, we extracted, because it's a transient model, we had to extract those years, you know, from the transient model and compare it to the analytical, which was for that year. And then the long term was just the whole period. So good calibration on that. Next. Okay, so let's talk about seawater intrusion calibration. So these are the chloride concentrations. We calibrated to milligrams per liter chloride at 17 wells, a total of over 200 targets. You know, the targets were selected in the areas where we had intrusion and around those areas. So we didn't go off into the creek valley where, you know, we didn't have intrusion. So, you know, we have a lot more water quality data than 200, but these are the ones that really apply to calibrating seawater intrusion. And that's, you know, over the base period. Again, using the target chemographs and some residual maps, we're adjusting parameters, and then, you know, going back to the water level calibration and so forth. So the statistics, again, the graphic showing the actual observed versus model, it's the same idea as the water levels. It's the observed minus the computed values. So those are the comparison of the two, and the perfect fit would be along that diagonal line. And you look at the statistics, the residual mean, again, is the average of all the values, and it's also well balanced. So minus 10 milligrams per liter chloride. So, you know, negative value indicates model values were slightly greater than the observed values. But in this case, it's very close to being well balanced on either side of that line. The root mean square error indicates the magnitude of the model error averaged 556 milligrams per liter chloride, plus or minus 556 milligrams per liter chloride. Now, you know, that may sound like a lot, but for the whole range of chlorides, which is close to 17,000, the scaled calibration statistic, which is the range of, or the root mean square error over the range of observations, that's a scaled RMS. At 3.3%, that's well below industry standard. Now, industry standard, GSI found a reference that had 15% for solute transport. I don't know that there's any reference for dual density, but in any event, this is well below and even the water level standard. Okay, next. So here's some calibration chemographs. Again, the red lines are observed or measured. The blue is computed by the model. And these are for lower aquifer zone D. You can see that the fit is not as good as the water level calibration. Computed values for 2 of the 6 wells are in the general range of the observed values top left. So the top left and middle bottom, they're in the general range. And then the remaining 2 wells, or the 2 of the wells have higher computed values. So the bottom left and then the top right, computed values are higher. And then the remaining 2 have lower overall computed values. The intrusion fronts are generally not as sharp as observed, and the front arrival times are not well defined, and I'll discuss that more on the next slide. Okay. Here are some calibrated chemographs for zone E. The fit's not as good as the water level calibration, but the intrusion does reach key locations. As with zone D, the computed zone E intrusion front is not as sharp as the observed front, and arrival times are not well defined. So by arrival time, I mean the timing of the initial break and slope when chlorides start rising, and the sharpness of the front being the slope of the concentrations. So for example, at LA15, which is the top right plot, the computed arrival time is about 16 years earlier than observed, and the computed chlorides are rising along a flatter slope than the measured slope before leveling off. That particular well, that zone E was cemented off in that well, so the leveling off is a real thing. It makes sense. In order to delay the arrival time and have a sharper front for this well and for some of the other wells, you have to effectively remove dispersivity from the model. Now, dispersivity is a major parameter in solute transport. And when you remove that, while you do visually create some better matches for some of these wells, you create other problems in the model. So intrusion starts going in places where you don't see it, where it's not measured. And it degrades the overall calibration statistic significantly. So, decision was made to retain dispersivity in the model and to focus on basin scale matching of the intrusion front position, which is what other seawater intrusion models north and south of us along the California coast do. They focus on the position of the front. You won't see this kind of statistical presentation in any of these other density dependent models that I've seen. This is going a step beyond what some of these other people are doing up to the north in Monterey and to the south in the Oxnard Plain. So next slide. So here's the positioning slide where we show the intrusion front for winter 2005 and summer 2023. The solid contours are observed. The dash contours are computed. Blue is zone D and red is zone E. So by 2005, the front had reached Palisades Avenue in zone E. That's LA 15, which is the well that was that was cemented off that I used as an example earlier. So we have a very good match between the position observed and computed position of the front in Zone E. Since 2005, the main change in that Zone E front, if you look over to summer 2023 on the right, is that the fronts moved past LA 11, which is at the top of the slide there. So LA 11 is actually in layer 7. This plot shows layer 5 in order to illustrate the matched observations of Palisades. But in layer 11, the computed intrusion front has actually moved into LA. In layer 7, the computed intrusion front has moved into LA 11, but not past it. So it's farther than it's shown here because we're in layer 5, but it's still about 1,000 feet separation there between the match for 2003 and Zone E at that location. So if you look at the position match, the current 2023 Zone E goes from being on target at Palisades to about 1,000 feet off at LA 11. The Zone D observed versus simulated is not as good overall. So the blue lines, as for Zone E, which are the red lines, there's uncertainty in the observed location of the front at LA 10 in the middle of the figure, and we've talked with that. Most of the folks are familiar with that well and how it's completed in 2 aquifers, and you get mixing, and then there's upper aquifer influence. In any event, the yellow shaded area on the 2023 side of the figure shows the range of the observed front at LA 10 between 2005 and 2024. So it's kind of swung between those two ends of that yellow shaded area, and the computed front basically runs through the middle of the range. So you still have an overall match of about plus or minus 1,000 feet. Now, that's the calibration summary. Now, let me say that accurately matching chloride values with density-dependent flow at individual basin wells over time is a much more difficult task than matching water levels, to say the least. And that's because seawater intrusion occurs along preferential pathways based on local channel deposition that can be highly variable within a basin. We have useful lithologic information for about 200 wells, including 40 key wells, as I mentioned, many with E-logs. But what that gives us is it gives us a good characterization of the aquifer and aquitard vertical thicknesses and the general structure, but not the fine screening or the fine resolution needed to characterize the horizontal channel geometry within aquifers. So think of it, with 200 wells, if each well gives you a square foot of, vertical information, that's 200 square feet, cumulative square feet of data for any depth horizon going down in the borehole. And that's over about 10 square miles. So you've got these vast areas where you can have channelization and things going on where the solute wants to go. Okay, it's not pressure, which basically goes in all directions. The solute follows these pathways, and there are ways to improve that representation using geostatistics, but that would be for a future effort. I mentioned that you won't see the calibration statistics or targeted matched chemographs presented for other California basins with dual density seawater intrusion models. They focus on the position. For example, Salinas Valley model and the Oxnard Plain model to the north and to the south of us, they only compare the position of the front, the measured position versus the computed position. In the Salinas Valley, the computed intrusion front is up to 2.5 miles from the measured front. In the Oxnard Plain, the difference in position is up to 1.5 miles. So, those are bigger areas, understandably. You could have, greater differences, but still, you know, if you look at the match we have in the transient model for our area, you know, plus or minus 1,000 feet is basically an order of magnitude better, and pretty good for our purposes. Next slide. So we had 2 peer reviews performed, one by GSI Water Solutions, one by Linker, One Water. These peer reviews are in the appendix of the model report. And I worked with the peer reviewers to explain the model application, answer questions, provided them with the files, supporting files, draft report, the baseline current condition scenario, so they could see the application. And, you know, the transient model meets the industry standards for calibration. And both reviewers agree that the model is suitable for applications related to the water recycling facilities planning study. And I put some quotes there. The Linker One Water quote is paraphrased from the TAC meeting. Their actual peer review was prior to my response. And, you know, we had meetings and we talked about it. And then they were focused on the conceptual site model. And we had done a lot of work on that. So, you know, in the end, they, you know, they use the term they're comfortable moving ahead. The GSI, they were more focused on the model itself and performance of the model. And again, they thought it was suitable for long-term regional evaluations, water and land management plans. And they said it's not yet suitable for project level evaluations conducted at local spatial scales and shorter term, i.e. monthly temporal scales. You know, so when you talk about the model grid, you know, our basin scale management, you know, is going to have distributed pumping, you know, upper aquifer development over a wide area, you know, creek discharge and capture over a wide area. You know, we're not doing a street corner project and looking at very fine-tuned things. So, you know, really the application both agree that it's for what we're doing. Basin scale management, long-term sustainable yield estimates, comparison effects of reuse alternative projects on sustainable yield, those are all fine. Next slide. Okay, current condition baseline scenario. This is a scenario that was run. Next slide. This is a scenario that was run to evaluate whether basin scale pumping over the last 5 years of the base period was sustainable without inducing seawater intrusion per the adaptive method. The adaptive method was adopted by the BMC board and established threshold lines in lower aquifer, zone D and zone E, representing the leading edge of intrusion for fall 2021. Per the method, if the basin pumping causes seawater intrusion front to move inland of the threshold lines, the pumping distribution would be considered unsustainable. So, you know, we started with the calibrated model. We cycled pumping over the last 5 years. That would have been 2019 to 2023. And we cycled the recharge stream flow over the full 45-year base period. So that's just a repeat of the hydrologic base period climate. Cycled return flows over the last 5 years, and discharges were maintained at the full capacity. So the last year, because that would continue on into the future. And then we ran the baseline for 45 years. Next slide. So these are the results for zone D. The graphics show the intrusion front in summer 2023 and summer 2068. So that's the 45-year base period. The contour lines are milligrams per liter chloride, with the 250 milligram per liter line representing the intrusion front. The yellow line is the adaptive method threshold line. And as you can see, the current condition pumping, which averaged 1,830 acre feet over 5 years, the intrusion front crosses the threshold line near Skyline Avenue in the middle of the basin, which means the pumping distribution is not considered sustainable. Next slide. And then here are the same results for Zone E. In this case, the intrusion front does not cross the threshold line over the 45-year period. However, the overall pumping distribution is not considered sustainable because the threshold line was crossed in Zone D. So, there's always going to be uncertainty in model results. There's uncertainty in both the conceptual site model and in the model calibration. There are ways to evaluate predictive uncertainty in the model and to address conceptual site model uncertainty, but they will take time. What we have here is we have a model that's calibrated to basin scale. We have a methodology that you can compare apples to apples for different projects. And, it's a useful tool for projecting, next steps for basin management and kind of clarifying, what works and what doesn't seem to work. So looking ahead, we've got these other scenarios that are coming. We've looked at, the Broderson Mound and how that, relates to what we're talking about, sustainable yield, all these things. But as Dan said, that'll be for another meeting. So that concludes my presentation. Happy to answer questions. Thank you.
Okay, thank you. Is there any board member just questions to clarify the presentation before we get into more of a dialogue or anything of that nature? I'd rather hear public comment before we have a discussion.
Well, Mr. Chairman, I'm not sure how much public comment we're going to have. And as I indicated, I'm afraid, I'm sorry to have a hard stop at 3:30 in that I need to catch a flight for a commitment that's out of town. Certainly can catch up on if there is public comment that I miss because of my absence. But I think to be sure that my colleagues on the committee understand, let me make just a couple of comments here. As we know, there have been a couple of peer reviews of this. One of them complete, the GSI peer review, which, as I noted the last time we discussed about this, indicated the model was not fully set up to model chloride concentrations in individual wells. The other peer review is conducted by Linker for the county. I'll quote from that. That's again an appendix to the calibration memo, which says specifically the county needs to confirm that the behavior of seawater intrusion within the basin is being simulated and predicted to a reasonable level of accuracy and confidence, and that the model can be a reliable tool for evaluating various management alternatives to guard against seawater intrusion. In summary, our review suggests that the current model exhibits a number of issues that should be considered and addressed in the final report before the model can be considered a robust tool for the evaluation of management alternatives to mitigate against seawater intrusion. That statement is not contradicted in any of the, in fact, Linker didn't actually conduct a peer review that's attached. They asked a number of questions. The CHG responded. Subsequent to our last meeting, the county has reached out to the individuals that conducted the Linker review, asking them a specific series of questions regarding the reliability, the accuracy, and the certainty of predicting chloride concentrations. We have no argument whatsoever, and Mr. Harris is a noted professional and has done an extraordinary job in calibrating, doing the technical work that has led to what we see here. For well levels, we agree that that's excellent. The county does not agree that there is sufficient accuracy in the determination of chloride levels in any specific area in the model as it currently stands. And we've actually set up a meeting with Mr. Harris for the week after Labor Day to further discuss the level of certainty that we can be had for any of the results that are being presented as regards seawater intrusion. Yeah, quite simply, we believe there needs to be a sensitivity analysis, the various parameters, an accuracy analysis to see what the uncertainty is in the predictions that this model makes. And fundamentally, at this point, the county is not ready to agree to an unqualified conclusion that the modeling results indicate a continuation of sea level. We're happy to provide that a memo from our continuation of, it's not Linker anymore, but it is still the same individuals. It is likely the case that the characterization of the geology that controls the level of chloride in any given observation is probably not sufficient right now to accuracy, but there's more study there. But I would only direct my colleagues' attention to the graphs that Mr. Harris showed when he talked about the calibration of the observed versus the model chloride numbers. And those do not match very well in most of the wells that are being indicated. So all that to say that the county is going to reserve judgment on what the implications of the baseline scenario is at this point. We're not ready to go yes or no at this point. We need more information. That will happen in approximately 2 weeks. And again, I just wanted to be sure that my colleagues understood that county position before we take public comment. And again, I'm happy to remain here until I absolutely have to go at 3:30. Appreciate the opportunity to just offer you those observations.
Okay, thank you. Any questions? Stick to questions.
Yes.
Yeah.
Yes. I just have one question on slide 40.
With that slide 40 of the numbered slides or
It's
40?
the number on the slide
Okay.
40.
Yeah, thank you. Almost. Okay.
There you are. Okay, so Spencer, I see that I can see what it says for the yellow, but can you explain that just a little bit better so I can understand what that yellow area is?
So the yellow area encompasses all the interpreted locations of the seawater intrusion front between 2005 and 2024. So we have one for 2005, and then we started in 2015 or 16, and then we've had one since then. And what happens is, because of the fluctuations at LA10, that line goes forward and back. We know there are issues with that, with the numbers coming out, whether, how well they represent a discrete, zone E or D. So, we do need to have a better definition of the intrusion in D and in E, but this is the interpreted front for D for LA10. And the computed front just goes through kind of the middle of that shaded area. But if you go year by year, for example, in 2021, when we drew the threshold line, it was inland of LA10. And yet, in 2024, I think it was farther back. In any event, it does move.
Okay, I appreciate that. And as far as LA10 is concerned, so what you're saying essentially is because there were higher concentrations sampled in 10, that's why it's so much further in this last year?
Yes, yes.
Okay.
Where it's higher, it does move it in. Yes.
Okay, got it. Thank you so much.
Mhm.
One more quick one, Spencer. First of all, thank you very much for all the work through the years, many years of studying this basin. we know baseline scenario talked about the fact that current pumping levels and spatial distribution will not prevent saltwater from moving in further. The GSI, I think it was the peer review, talked about the transient model not being ready for project level review. But that, I'm not sure what project level means. Does that mean like the well that we plan to start operating on the other side of town, we're not going to be able to plug that sort of difference into this model and know exactly what that well, or have any idea what moving that well is going to do for us?
Well, I interpret what they're saying in terms of project is they're talking about a finer scale or a smaller scale project. In other words, looking down at a well and what the concentration is going to be at that well. Now, if you plug a well and look at the whole basin, then that's more basin scale effects. So it's just a question of stepping back far enough to be able to see the overall effect versus zooming in on one particular area where, because of the uncertainties, it could be here, it could be there. But if you step back, then the overall picture of the position is a better match.
So we'll get probably some idea of just how the operation of that well and trading it for this well over here would
Yes,
affect.
yes, we can do that distribution and its effects on the overall basin.
Great, thank you. And again, thank you for all the years worth of work.
Thank you.
Yeah, thank you, Spencer.
You've done the same.
One more question. Early on in the presentation, I didn't catch the slide number, but we were looking at the cross section, and there's a cross section that we've been looking at for many years that showed the basin and the how the lower aquifer, yeah, that one daylights at the creek, zone D. But when we looked at the new aquatards, I think it's the next slide or one after that, it didn't look like that daylighted at the creek. Is that still the case? I might not have understood this slide. Is it still?
It does. So
Okay.
if you look at that first orange line, that's the regional aquitard. And so you see it goes up to the creek, which is the depression as things flatten out, and it gets real thin and then it's gone. So that's essentially daylighting. And we also even though you're seeing the layers there, we can also join it with the Creek Valley alluvium using the same aquifer parameter. So even though it's a different layer, it's acting the same if we assign it, if we remove it as an aquitard and have it being an aquifer. So, yeah, this can be changed.
Okay, thank you. Okay, if there's no further questions for Spencer, we'll go to public comment.
You have a public comment and you're in the boardroom, please come up to the podium. And if you're online, please raise your hand. We will take public comment in the boardroom first.
Good afternoon. Thank you, Mr. Zimmer and committee members. My name is Jeff Edwards, and thanks to Spencer, I do have a handful of questions for him. To follow up on the question you posed, Mr. Zimmer, about the creek and lower aquifer interface. And my question is, do we know any more based on the transient model about the connection there? And to what degree we realize lower basin recharge from freshwater flows in the creek? The second question, it appears that there's been a folding in of an additional 285 acre feet of urban demand on top of our 1,000 acre feet of demand currently. How and why was that additional demand folded into the model? You probably know we have a water neutral policy for Los Osos. And so adding additional demand, not sure how that came about. Thirdly, we have a fairly burning question with the efficacy of Broderson. And I'm wondering, after 10 years of loading Broderson and the leach field system there, does the model tell us anything more about why Broderson's not working apparently, and what changes we might be able to make? And then lastly, based on the new model, is there been a calculation and is there a delta in what we believe to be the freshwater volume above sea level now versus what the steady state model told us? Thank you.
Invite public comment. We're not going to.
Hi, Lynette Brooks. Given that the transient model seems to be matching current intrusion relatively well, and that it predicts farther intrusion with current pumping, it is a large step forward in having a model that matches known intrusion and known data. So I'm very curious as to why the county for years has been willing to accept a model that was not really matching the data, that Spencer Harris's own reports would say things like, well, the model says intrusion shouldn't be happening, but it is. Why they were so willing to accept that model and are very hesitant to accept this model that is matching the data. That is making absolutely no sense to me, Mr. Gibson. Now, I will agree that there are some problems with the model. One, and the parameter estimation software could have been used, and then we would have these sensitivities, we would have prediction uncertainties, we could have all of that. The GSI peer review recommended using parameter estimation software, but it was not done. Many other recommendations from both reviews may also not have been incorporated, and those do need to be incorporated. Second, and related to the first, the report does not mention if manual sensitivity analysis were done for recharge and pumping. These values were estimated outside of the model and have uncertainty associated with them. How does changing them by 10% or something like that affect simulated water levels, chloride concentrations, and most importantly, where the intrusion front is? Third, the calibration does not capture seasonal variations in water levels in many areas and almost completely misses them in Zone E. Zone E appears to be isolated from seasonal changes in recharge and pumping in the model, but not in reality. Using the changes in water levels with time instead of just water levels may have helped determine which model parameters control those changes. As this zone is the zone with the most intrusion, because it is the deepest zone, it is critical that this part of the system be simulated correctly. Right now, it is not. Thank you.
Good afternoon, Patrick McGivney with the Los Osos Sustainability Group. Mr. Harris, we would like to express our gratitude for you being here today and our relief that you seem to be recovering from your health incident. In regards to our basin sustainability, Corey Hahn of the Planning and Building Department, in his presentation to the County Board of Supervisors, quoted you by saying, quote, "We have consulted with Cleith Harris geologists in discussions with them, and their determinations are that the basin is sustainable and there is capacity for further growth in the community," end of quote. Was that a correct statement from you? Mr. Harris, you know, for the last 40 years, our basin has never shown sustainability. Chloride levels have continued to climb. Nitrate pollutes our upper aquifer. Seawater intrusion continues. Water levels have dropped and are only halfway to where they were predicted to be by 2022. 3 of the 4 baseline goals for sustainability still have not been met, and the information given to the county allowed them to claim our basin was sustainable and ready for more growth. They rationalize this by using 2 metrics the Department of Water Resources warns is neither an indication of basin sustainability nor proof of. Those were the estimated sustainable yield and the basin yield metric. You presumably know that these are not metrics that show sustainability. So why did Cleith Harris geologists never contact the county and let them know that our basin was in overdraft and not ready yet for more development? That would have given Cleith Harris geologists a lot of credibility. The safe yields of the steady state model have never been correct, and you have stated that in yourself. in your TMs. Our latest approved sustainable yield of 2380 has achieved the highest chloride readings in all of the history of the basin yield management or the basin management. The annual reports, those sent to the courts, have always painted a rosy picture of our basin, all while chloride levels are climbing. Neither Cleese-Harris geologists nor the BMC have tried to correct the county in their dogma that pumping within the safe yield is a sign of sustainability. That is just not correct. The definition of a safe yield is where there are no undesirable results when pumping within the safe yield, such as seawater intrusion. As the voice of knowledge, Cleese-Harris geologists evidently never made this clear to the BMC. Now that the transient model's baseline scenario is showing that pumping at 1830 acre-feet yearly is not sustainable, and that the current pumping is exacerbating seawater intrusion, and that's just the baseline scenario using current predictions like 18.3 average yearly rainfall, Mr. Harris, we need to know what the future predictions will be, taking into account climate change and the predicted long-term droughts we'll be facing. If 1830 is too much, what are we looking at with less rainfall, less humidity, and drier earth with less capacity to absorb water? We have no other water source, and our community deserves to know what is being done to manage and save our basin from further degradation. So these are not rhetorical questions. We'd like to know what you expect, and we hope you can provide the answers. Thank you.
Becky McFarland, Los Osos. Thank you again for allowing for public comment and not giving in to requests to shorten our public comment period. I can't remember how many times at least 4 times when I've been here. It's been requested that our public comment time be cut, and I think it should be lengthened instead of cut. We are the public. This is our water supply. Thank you, Spencer. I wish I could understand all of that. What I do understand is that our water is not sustainable yet. I know yesterday at the Board of Supervisors, they were talking about, more infill on housing and putting things in, and I've said it over again and over again, but I'll say it again here. Why are we allowing guest houses, 2-bedroom, 1-bath homes that don't have to retrofit? They only need a ministerial permit. Why? They're not being counted in the growth ordinance. So it's a Trojan horse that got put into our town and onto our aquifer. And BMC, you should be asking. You've got a county person here. Ask them why they're basically cheating the system and affecting our basin. Something else that's not counted in the water is like even when they calculate how much water per person we're using, the water used outside is not calculated. I've heard anywhere from 20 to 30% of water is used outside. So we don't have the right answer of how much water people are using. So please, let's take care of this guest house nonsense with some backup from people in this town. 2-bedroom, 1-bath homes are being added, not in the growth ordinance, not retrofitting, and only given ministerial permits that don't go before coastal and do not have to notify their neighbors. Thank you.
Lindy Owen, again, Los Osos. I wanted to thank Spencer also. He's been here for many years following our basin, and I've learned a little bit. This was very confusing, but I want to go back to a basic issue. 50% of our water approximately is being used from private wells, which the county oversees and manages. Now, Mr. Gibson has told us there's no way we could put meters on so we could know how much that 50% is. He likes the idea of doing aerial overflights, I guess, to predict or to guess how much water the crops might be using, et cetera. The issue that I'm having a real hard time with is up in Paso Robles with their nightmare. Mr. Gibson has suggested and even proposed that they be charged to have private meters put on all the private wells, have meters. Just
Lindsay, I'm gonna interrupt you for a second. So we're on the model. And so if you could keep your
But the
comments
model
focused on
can't
the model,
show.
you're talking about a different water basin and such. So I apologize for interrupting, but I want to hear comments on the model. And then we're going to go to open public comment.
Oh, I thought we
you'll
had
have-
already had it and I missed it.
No, we're going to go
No,
to
but
that.
this model does have to do with 50% of the water being used is being put into the model. So saltwater intrusions come in one way, but it's also being taken from the other side. So I disagree with you. I think that all of our water basin should be counted and looked at. And I'm very tired of having 50% of it just be a guess. Thank you.
There is no further public comment in the boardroom, and there's no public comment online, so we will bring it back to the board.
Okay, great. Thank you. Time for discussion. All right.
Mr. Chairman, there were a number of questions, reasonable questions raised. Since they're largely technical in nature, I wonder if we could ask staff to collect those questions, prepare some answers, circulate them at the earliest possible instance, get them posted and distributed to our mail list, or we certainly can report. If there is conversation that my colleagues would like to have on this matter, that would be great, but I understand we have an action item in C that might need a unanimous vote. So if there's a chance we could get to that, that would be fantastic.
Yeah. We can certainly, I think there is value in having written response to the questions. Know how the other board members feel about that, but I think that would be acceptable to give Spencer time to reflect. Maybe Jamie can, go back to the transcript, look at what those questions are, get them down, talk about them in staff and have Spencer respond to those questions. Does that seem reasonable with everybody?
I don't have a problem with all of the technical questions being handled that way. I guess I would like to come out of this discussion with a better idea about time frame and moving forward and just what to expect in terms of adoption of this model and a new estimated sustainable yield, because as long as county staff reports keep referring to the fact that we have not adopted the transient model, they're going to use 2380 or whatever the old estimated sustainable yield is when they're processing building applications. And that is going on. So I guess, and I appreciate the executive director's report with updated information about the number of applicants processed and all of that. It helps keep an eye on this big picture, because that's part of the discussion that needs to happen now. We've got people hanging that are really, they're concerned when I talk to them about what's going to happen when they got their hopes up so high and what's going to happen now. And we need to be sensitive to those people. So a time frame is something I would like to come out of this meeting with, in terms of how much longer for amended peer review, I guess we'll call it. When do we think we're going to get to decisions? Is it going to be through the growth management ordinance? What's the timeline? I mean, I think we need to start those discussions, and if we're going to do an amended peer review, especially, we need to have an idea how long that's going to take.
Yeah. I am in agreement with that. When I was talking about written comments, I was referring to Spencer and those technical in nature, because we'll spend a lot of time talking about those.
So my concern is the bigger picture.
Yeah. And I mean, generally, we have new information that we need to digest, understand, and confirm. But it also, we have valued the tools that we have, and this is a new tool to make decisions. And so, we've waited for this model. We've, have the presentation, we have the information. Now what I see is this is a baseline scenario. Are there different model runs we need to staff needs to work on that. That's what I would like to walk out of this. And I mean, to me, I value this information as hard as it is to receive, or I'm not an expert. I'm relying. We had 2 peer reviews, and in my opinion, it's time to move forward, and we realize we have work to do, and let's hope that gives us clear direction on how to move forward.
You touched on one other thing that I would like to call attention to, and that is the fact that new information doesn't mean that you were deliberately using bad information in the past. I'm kind of tired of hearing that Spencer, how could you, well, I wish we'd been able to give you better tools. So we did the best with what we had, and now we move forward, and that's what we need to focus on.
I agree, Mr. Cesena, that we use the best available information, and we're working to see about upgrading. I think it's good to remember also that the transient model is actually part of a larger study on the recycled water distribution, and so there are model runs yet to be run. I wonder if Mr. Heimel could give us the brief on when that project as a whole is expected and needs to wrap up.
Well, before we go there, let's just talk about this general sense of this project, if we can, I mean, the model and our interpretation of it. And, because I think along with what Chuck was referring to, we had a model, we made decisions, we implemented projects. Chuck mentioned he's tired of hearing a certain negative sense to that. And I think we have done good work in this basin. It'd be interesting to see where that, chloride level and movement would be without the work we did too. I mean, that just, I don't want to lose sense of that we've invested a lot of time, energy, money, and had some very intelligent people working on this for us for many
Right.
years.
So let me speak to, again, the county is continuing trying to finalize the peer review that Linker started, that the principles of that. We meet in the first week of September. I would imagine within 30 days, we could have that peer review finished. So I would expect without promising, because others are involved, that we might have that by the first week of October, which would fit well into the lead into the discussion of our yearly setting of a sustainable yield. So I think all that fits with what's ahead of us.
So that peer review, is that solely going to focus on the chloride?
Those are the
parameter?
questions. Those are the outstanding
Okay.
questions that are being considered. So,
Yeah.
I am interested in seeing this concluded as soon as possible, and I'll keep moving on it.
Okay. Yeah, and I mean, there are additional runs and scenarios. I think that we should ultimately have staff develop what those runs are and figure out what additional information we need to obtain from this model. I guess the question is, does it come after this chloride peer review, or are there models that are separate from? We talk about the Broderson and impact of recycled water. Could we run those scenarios now versus waiting, the waiting? Can we walk away with here with some action items that we can have staff working on and utilize this model, I guess, is what I'm trying to ask.
Yeah, so I think I can speak to that. I mean, it's in the Basin activities status update, which is the new name for the executive director's report later in the agenda. But and I don't think I actually got that exactly right, but we'll get there. We have a deadline to complete the work that's being funded by the Water Recycling Funding Grant, and so those additional scenarios are ongoing. We have to submit a draft of the report to the state board by the end of the month, and then the final by the end of October. So yeah, while, so the consultant team that's been working on this has been continuing to work diligently towards the completion of that project, because we have a very strict deadline to get that work done. And we've already requested a couple of extensions. So
Will that chloride peer review be part of that work that's got to be done by the deadline, or is this a new item?
not under that current schedule. Yeah, we're not going to have time
okay.
to get the results of an amended peer review in early October, and then make any changes, rerun scenarios, update the report, and then submit by the end of the month. So I think, and I think that's fine. The state board, they want us to complete the scope that we have. If we continue to refine the model at some point after that, then we have the ability to run our own scenarios. Now, granted, those will need to be BMC funded. We will have utilized the budget, and I think regardless, we've utilized the budget that's available from the grant anyway, with the scope and then the additional peer reviews and even some of the additional requests we're going to be asking of Cleath Harris geologists are beyond what was originally scoped. And so I think we're going to have to talk about how we handle that and, you know, through technical support or contingencies. But as I see it, unless the board would like us to request an additional extension, I think we need to move forward with the model that we have today, complete these scenarios, and we have the opportunity to rerun those scenarios if changes happen to be made in the future. I mean, they're not
Okay.
locked in stone.
And so just to clarify, the chloride, that's, the county's doing that, is that?
Well, again, that's the follow-on. What I have asked is to essentially complete the Linker peer reviews. My view that Linker didn't actually do a peer review per the document that's attached to the calibration TM. That they did not render an opinion in that. And so I'm asking them to render an opinion. Dr. Reilly concurs with that, and the meeting to work forward on that is first week September.
Okay. Thank you. Appreciate it. Beth.
I don't have a whole lot, but I think the one thing that I just want to say for context, you know, I can see the things that came up in the model and the questions, and I very much appreciate everything you've done, Spencer. I think you've worked so hard on this and you've gotten it. I mean, I would say 98% of the way there. Maybe there's some things, and that's just to where we start using it. So I just appreciate the time you've spent on it. But with regard specifically to the chloride, I just want to say there are certainly things that could be improved and those will take time, but while the model does show a lower chloride in some instances, it also shows a higher chloride in some instances. And so it kind of falls, in the middle, which when it comes to models like this, I think that's pretty normal. We can make it better in the future, but I certainly don't think that the model itself is insufficient for what we need it for today. So thank you again.
Thank you. Last, just the comment on the growth perspective. We do have the growth ordinance that we worked on with the county, and we value continuing to have that, those meetings and those conversations. I think overall there is some checks and balances built into that growth ordinance, right? And so regardless of what the model puts out, the growth ordinance has certain checks and balances in it as far as how much growth. And, over time that'll tell, that'll give us the direction, I guess, on how much growth we can actually handle or not in Los Osos. So looking forward to understanding that from staff too. Now, what is our future? We're going to have to come back with a sustainable yield change confirmation. We're going to be addressing the sustainable yield. I would like to do that sooner than later. I wouldn't like to wait till the last meeting in December to do that. I'd like to do that as soon as possible. And then, some prediction on what does that look like and how does it fit into our growth ordinance moving forward into the following year, which I believe would be 2027. Is that correct? Like we're 1 year advanced from, it would impact 2027 growth numbers. Right, we're 1 year.
Yeah, well, we can work on that.
Let's fine tune that.
But yeah,
understanding.
at its core, the BMC is tasked with adopting a sustainable yield for 2026.
Yes.
That before the end of 2025.
Yeah.
And then how that plays into the county, I believe the county's determination on the growth management ordinance is in the fall or in similar time framing. So,
Yeah.
but we can coordinate. We do have reoccurring meetings with county planning representatives, and
Yeah.
so
I see that as another pivotal conversation. Don't want to wait and be under a time constraint of talking about it, hearing public comment and those kind of things. So the sooner we do that, the better. Trying to save time for our last agenda item. I think
2 minutes back.
any further comments before we close this item? Okay, we're going to close item 9A and move on to item 9C. Let me get back to my agenda here. 9C, which is LA 16, LA 42, LA 43, and LA 44 wellhead survey quote.
Yeah, so to accurately measure elevations of the groundwater level, which is of critical importance for all of the things that we're talking about, we need to have accurate reference points. And so the way to obtain that, we've done several iterations of this in the past, is to hire a licensed surveyor to come out and survey the wells that we have, and then that data is available when the hydrogeologist goes out and measures the depth from that reference point to the groundwater. And so we've got a proposal from the surveyor that's done previous work for us to survey several wells, a couple of wells that were modified, and a couple of the newer wells, so we can have that accurate elevation data to support our monitoring program.
Asking for a budget adjustment.
Yes, and to fund that, thank you, Bruce and Jamie. We do have a rollover budget from the last calendar year that could be specifically for the LA 14 and 16 projects that could be utilized to fund that.
That's good news.
Yeah. And what was the total amount of that project again?
2,500
Okay.
for a survey of
Oh, yeah.
4 wells.
Okay. We'll go ahead and go to public comment on this item.
If you have a public comment and you're in the boardroom, please come up to the podium. And if you're online, please raise your hand. It looks like there's no public comment in the boardroom or online.
Okay, we'll bring it back to the board.
I'll move staff's recommendation.
I'll second.
Okay.
All in favor?
Aye.
Aye.
Any opposed? Motion passes. Thank you.
Okay, thank you.
Barely.
Consent agenda while you're here?
Sure.
Can we handle that? Okay, we're going to jump back into item 6 and cover consent agenda. We have 3 items on consent: 2025 financial reports, approval of minutes from the July 16th, 2025 BMC meeting, and approval of proposed contingency use.
Yeah, in the interest of time, any questions from the board?
No.
No
All right, just a poll.
Public comment?
If you have a public comment and you're in the boardroom, please come up to the podium. And if you're online, please raise your hand. Looks like there is no public comment in person or online.
I'll move to approve the consent agenda.
Second.
All in favor?
Aye.
Any opposed? Motion passes. 4-0.
Okay, thank you.
Colleagues, thank you for your indulgence. I appreciate the accommodation here.
Okay, sure. Have a good day.
Flight.
Okay, jumping back to our agenda. We'll go with item number 4, board member comments. There are no comments? Okay.
The next meeting.
No special presentation. I don't think we have to take comments, public comment if there was no comments. Is that correct? Yeah, we're gonna do that next. That's coming. Okay, so we've made it through 6, the consent agenda. We're on item 7, which is public comments for items not appearing on the agenda.
If you have a public comment and you're in the boardroom, please come up to the podium. And if you're online, please raise your hand. We will take public comment in the boardroom first.
Wow. Okay, here we are. My name is Deborah Howe, and I'm here to represent the Cabrillo Estates Property Owners Association. We want to thank the BMC for their letter of support that was sent into Public Works. I have a little update for you if you're interested. SAPOA hired an app called Election Buddy to send out a straw poll to all property owners, 188 property owners. And of those 188 property owners, 73% responded to this straw poll. And the results are 75.14% said yes, they would like to hook up to the sewer, and 24.86% said no, they would like to stay with the lamp. And since we're going to, I mentioned the lamp, I'd like you to know that at LOCAC, Marissa Consuelo, I think I'm pronouncing her name correctly, I could be wrong, with the county is going to be doing a presentation at LOCAC about the local area management program, what it is, how it works, what the requirements are, and who it applies to. So if you don't know about that and you want to know about that, come to the LOCAC meeting on Thursday. It's next week, 6:30 on Zoom. And if I could say one more thing, other comment, and that is on recycled water. Should the CSD be successful in their attempt to acquire Sunnyside School, it would be great if we could have recycled water at that location. We found out today from the assistant superintendent that the cost of water to water the fields there is over $100,000 a year. I don't know what that is in acre feet, but I can tell you that that's potable water. And if we had recycled water, it would go a long way. Thank you.
Hi, Lynette Brooks, and we seem to have lost even more people, didn't we? 1, 2, 3, 4. Okay, I guess we only lost one. And he's heard this all before, because I warned you that I would be talking about this every time until you do something about it. Sustainable yield. It's not on the agenda. You have a model and data that show that the sustainable yield is less than 1,830 acre feet a year. And you are at least starting to discuss the fact that you need to discuss it. So that's an improvement. However, you need to be taking stronger action. You need to be going to the county now and saying, we were wrong. And I know, Chuck, you don't like hearing that, but you were wrong. It was an old model. It was the best at the time, but it was wrong. And you had data that showed you the model was wrong. And this isn't on Spencer. This is on the BMC. You chose to ignore all of that data and just go with the model number, even though you knew that wells were getting worse. The stipulated judgment states that it is essential that the Basin Management Committee have flexibility to adapt to changing conditions. This is a changing condition. You need to come out with that sustainable yield number, reduce it as soon as you can. It's the only fair way to prevent future homeowners from spending money on architects and engineers because they may think they might be on the build list next year. It is also not reasonable to say, well, we're going to use a 5-year average if that average is based on a 2380 sustainable yield that really never was. I've also previously said that the current definition of sustainable continues to allow saltwater intrusion over large parts of the basin, giving up a large supply of fresh water. You need to redraw that map. The one that shows that straight line at the farthest intrusion, take that back. Take it back to where saltwater really is. Don't let it take over all of Baywood. And in closing, once again, the BMC is holding a regular meeting during working hours. The public is interested in the new model. As you can see, we had more people than sometimes, and in what the BMC is going to do about it. But you still refuse to advertise and hold a Saturday or evening meeting. Thank you.
Patrick McGivney, the Los Osos Sustainability Group. My last month's comments expressed dismay that none of the 5 issues Director Reinecke had presented in the June meeting had been addressed. I now express the same dismay. These were all issues that were requested to have an action measure taken by the BMC, items to be agendized and discussed. What progress has been made in resolving any of these issues, like to prioritize the reduction of pumping of seawater intrusion, to stop seawater intrusion, or use the MIDAS study as guideline for where conservation is still needed in the community, seek out solutions to reduce estimated pumping from private well owners, including agriculture, insist on maximal use of recycled water in each possible areas of Los Osos. This would require a community-wide conservation plan as mandated in the Basin Plan. What progress has been made in any of these? Other issues of concern that she outlined were connecting all remaining non-sewered homes to the sewer collection system. What has happened with that? That was all homes, not just Cabrillo. And there was a caveat to that, and that was equity for all users. Right now, saving our basin is only supported financially by half of the community. Let's get the other half involved, including ag, to start paying their fair share. Another issue was implementing a stormwater recapture program. In the last 50-plus years that I've lived here, I've seen a tremendous increase in stormwater runoff to the bay. This is not because it rained more, but because the infill that the county instigated in the late 70s and 80s with 1,500 new homes. Once open fields are now covered with homes, driveways, and patios, all running stormwater into the bay. With a drought cycle upon us again, we need to capture as much runoff as possible for recharging the aquifer. A huge concern that she listed was adding forever chemicals, PFAS and chromium-6 to our basin management plan. This needs to be addressed. We need to start accounting for these pollutants and how we will filter them out in our safe drinking water. And lastly, refocusing Title 19, the retrofit to build program, into the retrofit to save water, basin water program. Any water we can conserve, we do so to help save our basin, not for new development. Let's make that a policy and make it stated. So why haven't these been on the agenda? A director has requested them, and according to policy, that's all it should take. The transient model and baseline scenario presented in June was pretty clear and was expressed by the 3 water purveyors. Our basin is in overdraft and seawater intrusion is continuing. What about the 3 purveyors write a letter to the county requesting that no further development of water intensification be made until there is conclusive evidence to show our basin is sustainable for additional growth? That would show real community support. Thank you.
Richard Margetson. Deja vu for you two. Didn't this scenario of Bruce today remind you of past meetings? When he doesn't want something to happen, he could have went to Spencer. You guys could have went to Spencer and said, "Hey, Spencer, are you ready to answer these questions?" But no, this is going to give him another month. And then he's going to delay this peer review. And what are we going to end up, Chuck? December. And if he can push this off, Chuck knows what I'm talking about now. If he can put this off, that there's not a decision made by this board about the sustainability yield, won't happen until next year, correct? You have to set that by the end of the year. Be careful. The minute qualified questions got asked from the audience, he leaned into Mark, and then he leaned into staff about, well, we should probably get, I could tell by the way he was doing. He was wanting the answers to be in writing to get back. That's another month. By the time that gets that, and the public gets them and gets an opportunity to comment on them, we're another month's gone by. He's been doing this for 20 years. The first retrofit for sale ordinance that came up, he delayed that thing because there were so many errors in it for almost 2.5 years at the Board of Supervisors until a member of county staff had to come up and say, the public was right. And they changed it. That's his MO. Be aware of it. Don't let him. There's a word I want to use. I'm not going to. Don't let him do that to you. You guys are all bright. You know what direction this needs to go. Move it along.
Good afternoon. My name is Jeff Edwards, and I wanted to talk a little bit more about the Broderson situation. Today, about 80% of our treated effluent goes to Broderson and has been for 10 years. That's a lot of water. Currently, the water is discharged into a series of horizontal leach fields. And there are a couple problems. Number one, there are performance issues with those shallow leach fields. Gophers are impacting them. There is sand infiltration. it really raises questions about the original design and construction. But more importantly, our goals for basin management don't appear to be realized or even in the works. The mounding that was expected, I don't believe is developing. It appears to be leaking somehow. Perhaps as one of my earlier questions, perhaps the model can help us with that dilemma. But what I'd like to suggest is that through adaptive management, we look at an alternative form of disposal. And back in the early 2000s, when the CSD bought the Broderson site, there were a number of tests conducted by Metcalf and Eddy. They drilled 2 dry wells. These are vertical wells, 8-inch diameter casings with about 120 feet deep. And they were loaded with water. And they performed very well. In fact, Metcalf and Eddy concluded that this dry well method is a technically feasible water disposal method at this particular site for treated effluent from the Los Osos sewer. And based on a 1.2 million gallons a day, they estimated about 23 wells be needed. We're about half of that. So 10 of these vertical wells to accommodate the flows at Broderson, introducing the water at a much lower depth, and in my view, perhaps a better approach to disposing of the water and realizing real seawater intrusion mitigation, which was the whole idea in the beginning. Perhaps the model can actually test these wells somehow in this connection. So Public Works obviously is going to have to be involved. Mladen Bandoff at the County Public Works is kind of now in charge of water resources, and he's the guy there. Ironically, I'll just close with ironically, the water recycling planning study, which is about looking at what we're going to do with treated wastewater, among other things. I don't believe Broderson is in the WRFP. I could be wrong, but I don't think so.
Becky McFarland again, and I appreciate everyone else's comments. Yes, stop letting Bruce Gibson bully you guys. It's so obvious. It's so obvious how he bullies us and does not want our comment. We've seen those Christmas surprises or the surprise before the Coastal Commission thing where the CSD had to vote on that thing right away and that our basin was sustainable and all of that stuff. We're so sick of it. Can't just turn it in today. I mean, really, this is our water supply, and he and the county needs to show more care. I appreciated what, I know we're not supposed to say your names, but a certain member of the CSD said about, we need to know about these permits that are coming through. The county should be informing you and LOCAC on every guest house that's going in this town. I'll just keep saying it. I mean, it's ridiculous. No limit on the number. And there's people living them right now. And people at the county have been telling people, at least one man, it's the same as a granny unit. And people are building them because of that and putting their grannies in it, which I love grannies, but it's a water situation. So, you know what? I appreciate all of you that do stand up to our supervisor. But we need to stand up better as a group and you as purveyors. He doesn't have good plans for us or for our water. And it's just obvious. Stop letting him cow you guys. Stand up to him. I mean, I've watched him stand over people here and go, that's what it means, really? Mm-hmm. It's disgusting. And I appreciate what you guys do here because you have to sit there and listen to it for years. Thank you.
Hello, George Hinkins, Los Osos. I'm hearing all of these discussions about, trying to maintain the basin. And my question is, what is the plan if you can't provide enough water? The basin has failed. You can't get enough water out of wells to sustain the people that are here. What is the plan to address that situation? that we are trying to avoid.
There's no further public comment in the boardroom, but we do have one online. Lynette, all you have to do is unmute yourself.
Lynette Tornatsky, I live in Los Osos, and I have a few comments. One being, if we could get an update as the CSD is able to provide it on hooking up to state water, I think that would be useful in this context. Number two, I agree with Mr. Gibson. Answer the questions quickly before misinformation gets out there. Of course, it has already. There's more models to run, he said. Can we have a list of those models, what they do, and approximately when they might be available with the information they would have? And the last thing would be, some time ago, Ron Munz gave us a report on the water use during more of these guest houses being built. And there really wasn't any real difference between the water use before and the water use after. It would be nice if all three water purveyors could provide information on these guest houses. How many are there? And what is the impact on the water supply? Is it making us use more water or not? Anyway, thanks for your listening.
We have another public comment from Robert Sarvey. Robert, all you have to do is unmute yourself.
Thank you. My name is Robert Sarvey. I live on 4th Street in Los Osos. BMC spent $450,000 on this study. And all I've been hearing is the county trying to knock it down and drag it out because they don't like the results. The county's creating a situation here where you're fostering speculation that more building will occur, and you've created a false real estate market for vacant lots in Los Osos. And we're getting to the point here where somebody's going to sue somebody. And I hope it's not you guys, but somebody needs to step up here and shut this down. There should be no building until we get all this resolved. And we have this expensive study that says we can't keep going the way we're going. And all we're hearing is, oh, it's not proper. The county doesn't like it. And then the county wants to have a private meeting, with the people that created the study. That should be a public meeting, not a private meeting. And the committee needs to step up, just tell the county, look, we got to shut this thing down until we figure out what we're doing and whether this is sustainable or not, because this study we just conducted says it's not sustainable. Thank you.
There's no further public comment online or in the boardroom, so we'll take it back to the board.
Okay, thank you. We'll bring it back to the board. I think generally, hearing much of the same comments regarding our topic today, just generally, we certainly confirm that there's work to do, and having this new model is ultimately a positive step in the right direction for making those decisions. I think there is importance in us having a seat at the table with the county to discuss some of these planning and future growth impacts. Ultimately, that decision lies in their hands. We do have the ability to weigh in and make judgments on the water. I think that is within our purview here. We have discussed potentially the next steps on, what is going to be the communication from the purveyors directly to the county. We have been talking about that to some degree, and now we've ultimately been waiting for this information. We've been waiting to see how the reaction is. So I want to instill in you that it's not that we are sitting here idle and not paying attention to what's going on. And ultimately, we are going to make decisions in the best interests of the purveyors. I think, there is also a significant aspect that I've said before, and I'm going to stick to this, that we've always made the best decisions based on the information available to us. We do have new information. We are going to make those decisions. Timing, is it coming fast enough, quick enough? These are complicated decisions, and we need to ensure that when we're making that decision, we're comfortable with the information that we have to make the decision, no matter how difficult that decision is. So yeah, that's my response to today overall, our public comments, and
Well,
just
in
wanted to share
reference
that.
to that, where are we at with that joint communication? I think S&T furnished some talking points. We were going to put together, did we decide on a cooperative letter, individual letters to the county?
Yeah, that's good. We did decide on a cooperative letter. When we talked about it, we were talking about this information being pivotal, and I mentioned, waiting to see the reaction and what, hear Spencer out. Maybe it would change the letter in one way or another or not. So having a letter out before what we have today seemed premature. We felt that we would come back with that letter and continue that discussion. So I know that the CSD did make those comments, and
Well, now we conclude it with how concerned we are about any delay in the process. I guess that will be a good way to sum that up. I'm trying to look on the bright side, I guess, and the only thing I can see is that we're not going to need harvest wells down in Cuesta by the Sea because Broderson works so darn well. That was in the EIR many years ago. We were going to need wells down in Cuesta by the Sea to harvest all the excess. And the December drop, we'll be very aware of the December drop. I'll stop.
Yeah. So my comments, first of all, thanks, Mark, for standing up when you can. I empathize. Unfortunately, I heard your name, but I didn't write it down. The community. They come up here every month and they talk to us about how concerned they are. And I know Chuck and I have talked about it. We have homes here, This is a real life situation for a lot of people. And of course, we understand the desire for people to move in and live here because we know how nice it is. We get it. But the reality is there's something that we're facing. It's somewhat of an impending doom. And of all the people on the board, it's you and Bruce who do not face that same outcome. When he retires, he is done with us. And when you retire, you are done with this board. So it's important for you to understand too what the community is feeling in this situation and how showing up every month and seeing increasing seawater intrusion every year over year, is a huge concern to us as a community. And it's really hard to see us kick the can down the road when we know we have good information that we can use to make good substantive decisions about the future of the basin. So that's my comment.
Okay, if I could just respond to the comment about me and walking away from here. So I cut my teeth 20 years ago in Los Osos. I've been here ever since and gone through some significant changes, and I've seen a lot of development, lived through the wastewater. Ultimately, I stand here before you as a representative of Golden State, and Golden State is a significant water purveyor all throughout California. They're going to ensure that the community and Golden State customers have reliable water service today and in the future, no matter what that takes. So this information is not something that I'm holding. I'm making the decisions. I'm making these decisions based on Golden State Water, conveying that with a team of professionals that are helping make these decisions and how to manage the water source. So to think that, you know, I'm going to walk away from here, I will never forget about Los Osos, I can tell you that. But as a professional, as a representative of Golden State, you have a very significant resource available that I think is very beneficial to Los Osos, because if things do go south, you have a significant financial and dedicated professionals to come in and make a difference. So, yeah. Okay. Anything else? Okay, we're going to close public comment. We do have a couple more things on our agenda to address. We have the Los Osos Basin update report, item 8.
Yeah, thank you, Chair Zimmer. Yeah, so you'll probably notice, as I mentioned earlier, we renamed the executive director's report to the Los Osos Basin update report. You know, one of the primary drivers for that is, as the executive director team, we're not necessarily the primary authors for all of the content that's in there. And so we just thought it was good to just characterize that, yes, we are providing updates on Los Osos Basin initiatives. However, you know, some of the updates come from us and what we're working on, direct from the BMC, but they also come from county planning. They also come from county public works. And, you know, and so that's information that, you know, we request on the BMC's behalf, but really, you know, applies to the larger basin, and sometimes even outside of the context, specifically of the Basin Management Committee. I kind of, in the interest of time, I say this every time, we try to highlight updated information in underlines, and a lot of the underlined sections we covered in today's agenda. So I don't think I want to go through every one of the updates, but I did want to highlight one update specifically, and that actually falls under the County Public Works section. And it's another, you know, major milestone in the Los Osos water recycling facility. And that is the connection of the Los Osos Community Park, Los Osos Middle School, and Monarch Grove Elementary to the recycled water distribution system. That occurred in July, and those facilities are now taking delivery of recycled water and utilizing that for landscape irrigation and offsetting their use of purveyor water, which largely directly offsets or reduces lower aquifer pumping in the western and central portions of the basin. So that's a significant achievement. It's many years, potentially even decades in the making, but is, you know, a great example of one of the ways that we can help reduce lower aquifer pumping, which is largely one of the, you know, our most critical resources here in Los Osos. So I just wanted to take a moment to recognize that, to help quantify that, and just for people's understanding, you know, the numbers that we've been provided of urban irrigation is how all of the recycled water deliveries for urban uses is being characterized. You know, it was only up maybe 6 acre feet from June, but I don't know exactly when in the month those connections were made. But the estimates that are included in the water recycling funding study, I think, for the potential recycled water use at those sites is 30 up to 35 acre feet per year that could be delivered, and consequently that's 35 acre feet per year of lower aquifer pumping that could be reduced. So a significant amount of water for a community of this size. But happy to answer any other questions that the board may have on the man, I'm really gonna have to learn the name of this Los Osos Basin update report.
We'll all get used to it.
Yeah. Thank you. Yeah, I do appreciate the new addition of the retrofit program too. It's a great addition. Yeah, 0 certificates. We have 65 out there though. Yeah, would like to understand the status of those 65 at some point. What does that mean? Are those 65 certificates waiting to be realized and we've already, or be used and we've already realized the water, the water savings there. So, would like a little better understanding of what does that 65 mean? Ultimately.
And just quickly, I jump in. We've requested that additional information and so from county planning. And so hopefully we can have that for next month's Basin update report.
Thank you. And then just generally speaking, no certificates in 2025. So, the amount of growth and that we talk about, it's not as pressing as what, as concerning as may seem at this point. Okay, last of my comments. We'll go to public comment.
Thank you. Good afternoon, Jeff.
Can you hold on for just a second? If you have a public comment and you're in the boardroom, please come to the podium. And if you're online, please raise your hand and we will take public comment in the boardroom first.
Thank you. Again, good afternoon, Jeff Edwards. As you may have read in the director's report, the WRFP study supply alternatives analysis is due at the end of October. That's the adjunct to the transient model. And it's going to talk about what do we do with our wastewater, principally, along with state water. We know these things now. We don't need to wait for this. It was a requirement, but let's not pretend we don't know. We know exactly what to do. And if there's an urgency, as I heard from this committee this afternoon, let's get on with it. Direct your staff to move forward on the following projects immediately through adaptive management. Let's act. Run the model. Fund the necessary model runs that are needed to include the Program C #2 well, which may already be incorporated into the run, and the third Program C well, which is critical. The third Program C well is actually going to contribute the most to our safe yield, up to 160 acre-feet a year. Then we have state water. Let's fold those numbers in. We've talked about 200 acre-feet, up to 600 acre-feet. Let's run the models with those numbers. What are we waiting for? I can't imagine, because we don't have the funding. You've pissed more money away than we need for this in the last 6 months. Let's do it. Let's also look at Title 19. There hasn't been any lately. I think the program's been stalled out for a variety of reasons, which I won't go into now, but we know from the Madow study, there's 118 acre-feet minimum. I've projected up to 200 acre-feet. Then there's Broderson. What are we going to do with Broderson? And shouldn't that be in the model? Let's figure some of these things out. I'm feeling whiplash. Are we going to reestablish a safe yield? We've gone from 2760 to 2380. The court told us to start at 2400. Now we're going to 1830. What are we talking about? That's whiplash. There is no crush of growth right now. And those 65 certificates, those people saved water decades ago. That's accumulated. So, let's stop the Chicken Little kind of mentality. Let's focus, get your staff to do what he needs to do. Get rid of the paperwork, minimize the paperwork. Let's do something. This isn't that complicated. The KISS principle should prevail. Thank you.
Patrick McGivney, the Sustainability Group. I hope, Dan, that the PowerPoint that Spencer presented today would be available on the website. So that would be very nice. Also, as far as water usage goes, if we are in overdraft, any bit of water just exacerbates that. It doesn't make any difference if it's just one more house or one more bedroom or shower that's put in. Any more water that's used is too much more water. So it's not just a matter of we haven't had all that much growth. any kind of growth right now is exacerbating the fact that we are in overdraft. I mean, that's what the report's telling us now. So, let's not quibble about things that we can control right now. You need to write that letter to the county. We need to stop more growth until we have a sustainable basin. And you're responsible for that. You have the ability to deal with the water issue, maybe not the land use issue, but the water issue. And they can't build without you giving them water. And the more water we give away, the less our basin is going to survive. And the question that the gentleman asked here, not this, before he left, about what is the alternative? What's our next plan if we go dry, or if our basin is just so overwhelmed with seawater intrusion in 5 years or 10 years or whatever like that? What are we going to do? There is no water available right now. We don't have the money for a pipeline that we want to have. So we can't depend on state water at this point. We don't have any other water source but what you are trying to manage. And that's what we need to maintain. That's what the basin plan says to do. Stop seawater intrusion. That's the first obligation you have to do. So let's please get on with that. Thank you.
Richard Margetson. 0 retrofits in July. 0 for 2025. The majority, Mark, of those are going to be from retrofit certificates for building outside the prohibition zone, I would imagine. But the builders and the developers, they're having a hell of a time convincing people to change out a 1.28 toilet to a 1. They just are. It's the inconvenience. I mean, at some point they may have to incentivize people. I've talked about that before. I'll give you $100 gift certificate to Windows on the Water or something if you come in. But that savings is nominal. Most of the retrofits that people wanted to do or were required to do, they're all done. 87% of the community in the prohibition zone had to retrofit. Morris Shores is trying to put in those 10 mobiles. They've told the park that they have to retrofit 88 washing machines and 120 shower heads. And most of those people are like, I'm not changing out my washing machine so you can build on our play fields. That savings is just not out there. People are not motivated. If we still had a bunch of 3.5 gallon toilets, yeah, maybe people would jump all over it. But a 1.28 to there's very few 1.6s out, which met the requirement back then. There's very few of those out there. I'm in the business of seeing those when I'm dealing with properties. Most of them are 1.28s, and most of those people have no interest in changing them out.
Becky McFarland, thank you for the report and the new name that we're all going to get used to. I am curious, in you're talking about 35 acre feet that could be saved. In the big scheme, when we hear about seawater intrusion and stuff, how many acre feet is it going to take to stop it? It seems like we maybe it's just me missing that, but it doesn't seem like retrofitting or our family not flushing the toilet all the time is going to stop seawater intrusion or fix the nitrate problem that we were hoping would be fixed. So yeah, what else can we do? I've talked with people about, what if we guttered every household in this town and used that water in our yards? I've also heard there's no conserving our way out of this problem. And I'd like to hear, Mark, I appreciate when you do stand up for us and stuff, but what is Golden State's plan if this goes worse? And I mean, we're going to truck in water. Where's Golden State going to get the extra water to do that? And how much does that cost for people that can barely pay we want to stay here. we're thinking of moving. We can't afford that trash bill anymore, hardly. The water goes up, the electricity's got, we even have solar and our true up went up. Everything has gone up. Where, I like you, but where is Golden State going to get water to bring here? Are we going to truck it in like Oprah and those people? We can't afford to truck in water. Is it better if the water didn't go into the leach field and got used elsewhere? I don't know. I don't think, is it treated to tertiary? It can't be used for certain things. And I know farmers don't want some of it because of the salts and maybe the chemicals that are still in it. I think I mentioned before, I went out with the owner of Warden Lake, who has this idea that they want to, be able to dam up some water back in there and then somehow put it into the recycling system. Is that something that's cheaper than a pipeline? Is that more acre feet? I don't know, but I think, let's do some creative stuff. There's smart people around here. We ought to be able to figure out something, but I agree. Any extra water use does not help our seawater intrusion, and any retrofit program that does not include outdoor water use, and again, the guest houses. As one person said, oh, there was a write-up about it. Well, the write-up was about studio apartments in San Luis Obispo. They weren't 2-bedroom homes with people living in them full time. So anyway, yeah, this is a serious problem, and some of us live here, and we want to continue living here. I do thank you for what you do. I don't think you don't do anything. I've never believed that you did nothing. But we have tried things, and they haven't worked so far. Thank you.
Right, there's no further public comment in the boardroom and there's no public comment online, so bring it back to the board.
Okay, thank you. We'll bring it back to the board. Any comments on public comment?
I guess what would be the next step in running the transient model? Another scenario, I mean, how much money are we talking about for a model run? Is there a general ballpark, like the baseline scenario? That tech memo, do we have a price for that kind of thing?
That's a great question. I don't have a price.
Okay.
But that's something we can easily request of Cleatherapy geologists. I mean, historically they're very, cost effective. Spencer's, and Tim, who was here today.
Well, yeah.
So why don't we ask them of that? So that's a data point that the BMC can have in future decision making. I think in my experience in other models, it's, it's probably, I hate to throw a number out there, but several thousand to $6,000 a scenario, something like that. Depending on the level of documentation.
Until you start
required.
talking 5 figures, I don't blink.
Yeah.
Because we just have to get on this.
Yeah.
Like we need the
built
cooperative
tool.
letter. We need that purveyor's letter. Because
So from what I understand along that line, Chuck, is that they're gonna, at the next staff meeting, you're gonna talk about what are potential scenarios for model runs and maybe include a cost estimate for that too.
Good. Okay.
Yeah.
Yeah, and there are model runs that are being done as part of the water recycling funding study. And those are funded through the grant. And so we'll have those. We didn't have those at last month's presentation, but we will have those in September.
What would those involve?
I think there's a model run for recycled water injection. There's a model run for ag exchange.
Okay.
There may be a model run for upper aquifer nitrate. And a lot of those model runs, indirectly involve Broderson. So it's instead of water going to Broderson, it's water going to other uses so that we can quantify the benefits, if it is beneficial to put that water somewhere else other than Broderson.
And those need to be completed by mid-October?
Yeah.
Okay.
Yeah. So those results are all going to be available in the coming months.
So just to follow up, so are you planning to work on the sustainable yield after those model runs or at the next So that puts us into November then.
No, I think the intent is to work on the sustainability. Well, I mean, it's board direction, but if
That's,
yeah,
I wanted to start that
yeah,
now.
okay,
Yeah.
and I think we can do that.
Okay. Good. We don't necessarily have to approve it now, but we just want to start it and start that conversation and work through it. That's all
Yes.
good.
So would we have a target month ahead of December that we may want to try to have that?
Yeah, I mean, give us a target and we'll hit it. I mean, let's just playing it out, right? It's August, so we have a regularly scheduled meeting in September, October, November, and December. So we've got 4 meetings. I can talk with Cleve Harris and the staff representatives, and maybe we can bring something back. Let me talk with staff and Cleve Harrison and find out when we can bring it back, with the understanding that the board wants to see something as soon as possible.
Yeah. And maybe one thought would be in our next meeting, we can start the discussion on sustainable yield. That would be September, October. We look at the model runs that we have to, that are going to be completed, and then potentially bringing back the sustainable yield with that new information from the model runs in November, and have a good talk about that, because really the sustainable yield's not going to change until 2026, right? Or
The way the stipulated judgment is structured, we adopt the sustainable yield for the subsequent calendar year. So in theory, yeah, we would adopt it, and it would go into effect January 1, as I understand it.
Okay.
Yeah.
Yeah.
So in that case, then how does that interact with the growth management ordinance? Those meetings, because I believe those are taking place at the county. Is that November or December that they're going to have their acceptance meeting?
I need to coordinate with county planning staff on that to get that specific timing for when the county considers the growth management ordinance for the subsequent year. But I think we can work towards having something for the BMC to consider in the letter or the recommendation that gets made to the county, the groundwater sustainability department, who then makes a recommendation to the board of supervisors, is my understanding of how the process is intended to work.
Okay, that one last question on that. So the letter that you just mentioned, I was actually going to ask about that too. So has that letter been completed for 2024 yet? And does it incorporate anything from the transient model, if it has?
No letters have been generated. With the community plan, we're really just in the very first year of this. There was a desire to get the results from the transient model. Well, first it was the annual report, then the transient model. But yeah, so I mean, I envision that's something that we'll be working on next. Is now we have the transient model. We have a baseline scenario result. Baseline scenario. We've had the presentation from Cleve Harris, geologist, BMC. We have all the information that we're going to have in the near term to bring back to the BMC for their consideration with respect to a recommendation.
okay. All right, we'll close this item. Closing the let's see, what else do we have left? We've kind of marked up my agenda here and moved all over the place, but I think we've hit all of our areas. We are done. So last item, adjournment.
That was a good one.
Yeah. All right. Thank you very much. Appreciate it. Have a good evening.
Usually like December, the first week, right?